Hola chamas y chamos, welcome to ViteConf 2023. I'm pretty excited to be here because I'm going to present you today how VueJS is powering the TresJS ecosystem, a tale of a modern web development. My name is Alvaro Saburido. I'm a DevRel engineer at Storyblok. I live in Barcelona, Spain. I create content constantly on Alvaro Dev Labs, mainly about Vue, TresJS, and TresJS. I have a blog and a portfolio in this direction here, and you can always say hi on Alvaro Sabu on X and, well, Twitter and Mastodon, okay? So to start with, I have always loved video games since I was a little kid. And to be fair, that kid never grew up, okay? This is me with my cat Gerald playing video games. And I was fascinated by the time to play video games that were the 3D golden era, right? Like Crash Bandicoot, Legend of Zelda. And I wanted to start creating video games and such. But I ended up studying and working as a telecommunications engineer and then as a front-end developer. And I always have 3D like outside, right? I thought it was for really brilliant people until I found TresJS, okay? TresJS is a JavaScript library that basically leverage the efforts to create WebGL experience or rendering 3D scenes on the browser. And I found this course by Bruno Simon, the TresJS Journey, and I found out like I can do it. It's not that difficult, right? But there was a problem. The first problem was that most of the content was right on Webpack. And it's not that I have anything against Webpack, but I was not really comfortable with. And I started to get to know Vite and start creating all the projects in Vite. And I say, okay, there is nothing out there for TresJS in Vite. I'm going to start creating a boilerplate of TresJS with modern tooling, right? Basically, I don't want to play with you anymore. But there was a second problem, is that I was using VueJS. Most of my career from like 3-4 years ago is based on Vue. So there was some solutions out there. One was to change to React and use React with Fiber, which is awesome, or using TresJS, which was not maintaining anymore, okay? So that's why I ended up creating TresJS. So TresJS is basically a Vue custom renderer that allows you to build 3D experience on the web using Vue declaratively. So you can use your Vue components to create the scenes. Tres is a Spanish word for tree, okay? And it's pronounced tres. It's in reference of the TresJS library. That's because I'm Latin American, and also the French word was already taken. So why TresJS? So basically, to keep up to date with the latest TresJS with 0 to none maintenance, meaning that the users can just download the latest version of TresJS and it will work. Something that is lightweight and easy to use. Something that is verbose, that people can start creating components. Something that is really focus on the X, and that's something that I found on the 3D workflow in general for developers that is really complex to debug and also to maintain. Something that has TypeScript support, something that is performant even with the reactivity, and this is also possible because it's powered by Vite, so Vite gives a punch of the speed, and also create a 3D ecosystem for the Vue community. So to get started with TresJS, and funny enough, this is I'm using a slide dev, and this is a scene that is right here, okay? And I can actually move it. So it's live inside of the slide dev. And to get started with it, you can install it by using npm add TresJS core and to install as a pure dependency TresJS, okay? If you want to use TypeScript, you need to install also the types. Let's get started by setting up the canvas. So basically, everything that is going to be rendered is going to be rendered in a DOM element, a canvas DOM element, okay? So with TresJS, you only need to add in your template or your component a Tres Canvas component, okay? This is going to do all the magic for you. You don't have to care about anything, you need to import that from the TresJS core and add it to here. It's important that everything that comes inside is going to be in the domain or in the context of the custom renderer for TresJS. So it's important that all the components is inside of the Tres canvas. Let's talk a little bit more about setting up a scene. Okay, so every 3D experience out there has more or less the same components. Okay, so you have objects, which are the things that you want to render. It could be a sphere, a plane, simulated floor. You need a camera to see those objects. And once you're ready, you wrap up everything in a scene. Then the renderer is going to render it on the DOM element on the canvas. So to set up the scene, if you were using plain 3JS, you will do something like this. So you create a scene with the tree scene constructor. Then you create a camera using something similar with a perspective camera class. And then you create a WebGL renderer and you pass the DOM element where you want to render. Last but not least, you tell the renderer to render the scene with that specific camera. In TresJS, it's way easier than that. You just put the Tres Canvas component and you put the perspective camera inside. It's better to be verbose and add the properties and arguments to the perspective camera that you want. But if you don't add a TresJS camera, TresJS is going to do it for you. So how do we add an object? If we were using plain 3JS, we will do something like this. We create the geometry using one of the constructors. So the cool thing about 3JS is it has a bunch of different geometries already. So we can use the torus geometry. Torus geometry is basically a donut. I don't know why they don't call it donut geometry, but it's called torus geometry, okay? And these are some of the parameters that you add, like the radius and how many segments do you want to render, okay? Then you need to define a material, okay? So basically the geometry is like the structure of the object, and then the material is how the surface of that model is gonna look like the color, if it's reflective and such. Then we create a mesh. A mesh is the main object, like it combines both of them. So you pass the geometry and the material, and finally you add it to the scene. In TresJS, it's way simpler. So you have a Tres Mesh component, and you can pass as a slot the Tres Torus geometry, and look at that arguments here. So whenever you want to pass the constructor arguments, you can do it as an array in a property called arguments, okay, or args. Then you can pass the Tres Mesh basic material, and you pass a property. It can be color, it can be roughness, metalness, etc. So we are going to put it like an orange one. And voila, we have a donut that is orange. Cool enough. Let's dance a little bit. Awesome. So we have our first 3D scene using TresJS. So how is this working under the hood? Basically, what we do in TresJS is that we take all the 3JS components that we put on the template, okay? And we have a catalog of all the 3JS instances, and we convert them into components. So we take the latest version of 3JS, which basically is an object that contains all these different classes and instances. And then we do a little bit of magic there, aka the custom renderer. And then we convert them all in different view components. So we saw before like how we can start a component of 3JS instance by passing the arguments. So in the perspective camera, you can define the arguments for the field of view, for example, is the first number here. Then the aspect ratio, which normally is the width divided by the height of the screen. I don't remember what it's one. No, yeah, far and near and far. So how much the camera will render, okay? And this is basically the same as in 3JS, saying creating a new instance of the object and passing the arguments like this, and then add it to the scene. Let's talk about props. So once you initialize it, okay, you can also pass some properties to change. So in the perspective camera, we could even set up the field of view, the aspect ratio, the near and far like this, okay? This is gonna be the equivalent of doing a const camera and not passing any arguments as the constructor, and then just setting the property of field of view, aspect near, right, and add it to the scene. Then we have the slots. So we take advantage of the Vue API for slots for passing some arguments for the Tres mesh. So whenever you're creating a mesh, you need to pass or add it. A Tres stores the geometry. You need to add the geometry and you need to add the materials. So as I showed you before with the donut, this is how we will do it. This basically is creating a geometry like this in TresJS, and then a material, and then creating a new mesh, passing this as argument. So whenever you're creating the slots in a component in TresJS, you are basically passing as an arguments for the other object. To move forward with TresJS, it's important to mention that TresJS is not only a package, okay? It's an ecosystem. Why? Because you basically can do everything with the core package, but sometimes you can improve the developer experience by creating some abstractions that will make your life easier. That's the case of Cientos. So Cientos is a package, for example, that gives you a lot of different abstractions ready to go to use as Vue components or composables. So if you want to load a new model, for example, that you found in the internet, this is the way to go. We also have a work in progress. It's a post-processing one that creates effects and post-processing of the scenes. And who knows, maybe one package of yours is going to be in the ecosystem in the future. What is important here and why we are in the ViteConf is that all of them are built using Vite live mode. So it wouldn't be possible without it. Here is an example of how we use Vite to build the TresJS core. So this is from the config itself. And we have the build property with the library, and we create the ESM bundle here, okay? To get a little bit more advanced, we also set up some plugins in Rollup. For example, we auto-generate all the definitions for TypeScript based on the TresJS types. So we iterate all the types that come in TresJS and we convert them to component types. So what we do at the end is that we copy and paste this TresJS component into the final package. We also set a Vue use core, which we use a lot, and tree as an external packages, so they are not bundled on the final package. We also set some exports named and the globals to achieve this. Something that is important for us, and I'm gonna just show you here, is the hot model replacement. Okay, this has always been really tricky when you're dealing with TresJS because you need to dispose objects for performance reasons, and it's quite tricky. So if I show you the video here, essentially what we want to achieve is that the user can change anything in the template or in the script, and you see immediately the object being changed in color, right? But this is quite tricky, and we still have some issues with it that we're working on. So if you're experienced with Vite and hot model replacement, please help us out, okay? One of the ways that we are using the API from Vite is using import .meta.hot, and on Vite after update, this is an example of how we deal with the disposal of the scene. And then we render the scene again, we update the matrices, and we resume the render loop, which is the one that helps you out rendering different animations and such.
1 week later.
Now, let's all pretend that I didn't record this a week before the other recording, because I just forgot to add that we also use Vite for the documentation. So all the documentation in the TresJS ecosystem is actually done with VitePress, and we couldn't see any other way of doing the documentation without it. VitePress is a power static site generator, and we host it on Netlify, okay? And it has been incredibly powerful because we also can embed the stack blitz examples that we have. And we can embed just Vue components with the scenes like examples and so on into the documentation. Also, the syntax highlighting and the way it is organized is really simple to use. We also use Vite for testing. So we are using vitejs. It's kind of hard to test 3D stuff because everything is happening in the canvas. But we do have some utilities. We do have some stuff that we test with vitejs. Also, for example, we're working on Vue GUI, like a graphical user interface to the controls, similar to use TwigPaint. And we are actually testing the components, everything with vitejs. So now we can continue with the previous one. Here are some of the resources if you want to continue learning and playing with TresJS. We have the documentation for TresJS, the core for CentOS. We also have a playground. It's a Nuxt application, okay? With all the examples and cool stuff that we have built with the library, so you can see how you can build it yourself. We, of course, has the stack list collection. We have a Discord community with geometries, materials on how to achieve everything that you need for TresJS. I want to give a huge thank to the contributors, especially the core team that is conformed with Jaime Torrealba and Tino, and all the rest of contributors that have helped us building TresJS as it is right now. So big thank you to you. And if you want to contribute, let us know. Your picture can be here, okay? Also, I want to thank my sponsors, okay, Danny Devs, Mark Bakes, Easy Themes, Bruno Perel, and Basilis. It's really important for us to have that little help out. If you want to help, you can begin by starting the repo in GitHub. You can spread the word, talk about TresJS, let us know. And you can also sponsor the project. We're basically doing this project because we are really passionate about 3D and we wanted to do it in Vue. So any help that you can give us to maintain all the packages and continue innovating in the DX of it, consider sponsor us in GitHub. Final but not least, a special thanks to all of them that they have helped one way or another to the TresJS success. Thank you very much. And this was everything from the TresJS ecosystem using VueJS.